Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at affine ciphers. So a cipher is just a method of encryption. We put a number into that cipher and it spits out another number. For an affine cipher, we take our number, which corresponds to one of the letters, we multiply it by some number A, add some number B, and then reduce modulo 26. We then have another number, we convert back to a letter. So for affine ciphers, the key is the pair of numbers A and B. These need to remain secret. We need to know them in order to decrypt. So let's look at an example. I'm going to encrypt the word Andrew using the key 7, -3. What that means is I convert each of these letters to numbers. So that comes from the table in the notes. You can also look up the shift cipher alphabet table because this is a type of shift cipher. And what I do with each of these numbers is I multiply by 7 and subtract 3. So 0 times 7 subtract 3 gives -3. 13 times 7 minus 3 gives 88, and so on for the rest of the numbers. So after I've done that, I need to reduce each of them modulo 26. So I want the least non-negative residue so I can convert back to a letter. So -3 plus 26 gives us 23. 88 is equivalent to 10 mod 26. 18 is equivalent to itself mod 26, and so on. Now, using that same alphabet table to return to text, I have 23 corresponds to X, 10 corresponds to K, 18 to S, 12 to M, 25 to Z, and 21 to V. So we have turned this word here into gibberish. The idea being if someone were to intercept this message, they'd have no idea what we're talking about. All right, let's now look at how we decrypt, how we would go from here to here. So here we have our ciphertext. We're going to decrypt by reversing what we did. So we multiplied by 7 and then subtracted 3. So here we're going to undo subtracting 3 by adding 3 to each number. But then we need to undo timesing by 7. So we can't really divide by 7 in modulo 26. What we have to do instead is multiply by 7 inverse. Okay, so what's 7 inverse? Well, remember there's two ways that we can figure this out. Firstly, we can write all of the numbers that are equivalent to 1 mod 26. So 1, 27, 53, and so on. And then we stop when we get a multiple of 7. So that turns out to be 105. So 7 times 15 is 105, which is equivalent to 1 mod 26. So the inverse of 7 is equivalent to 15 in mod 26. So remember the other way that you can find an inverse, you can raise it to the power of phi of the modulus. So phi of 26 is equal to 1 times 12, which is 12. So what we can do instead is calculate 7 to the power of 12, modulo 26. You also get 15. Either way you do it is fine. So because 15 is the inverse, what we're going to do is we're going to add 3 and then multiply by 15. So if I add 3 here, I get 26, which is equivalent to 0 mod 26. 0 times 15 is 0. So here, add 3, I get 13. Times by 15, I get 195. So then I go 18 plus 3, 21, times 15 is 315, and so on for the other numbers. So when I have all of these numbers, I'm going to reduce them modulo 26. So 0 is just 0 mod 26. So 195 is equivalent to 13 mod 26. 315 is equivalent to 3 modulo 26. 225 is equivalent to 17 mod 26, and so on. So now that I have my numbers, I just convert them back to letters using that same table. 0 corresponds to A, 13 to N, and so on. See, I have recovered the original text, the plain text. So just a note here, when you choose A, it has to be co-prime to 26. Let's look at what might happen if you don't follow that rule. So let's say we chose that A equals 13. So let's look at the multiples of 13. 0, 13, 26, 39, and so on. The problem is that each of these numbers in green is equivalent to either 0 or 13 mod 26. So if I chose, say, A is 13 and B is 0, every single one of these letters would map to 0 or 13 mod 26. Every single letter would map either to A or to N. So that would be a problem. If you have multiple letters mapping to the same letter in your ciphertext, it becomes really hard to decrypt. Of course, you've probably already figured out that we'd have a problem at this step. 13 is not co-prime to 26, so there is no inverse of 13 in modulo 26. So this step here, where we have to undo something, that wouldn't work. So make sure A is co-prime to 26. There's no restrictions on B because we're adding, it doesn't matter, but we may as well choose B to be between 0 and 25. There's no point choosing a number like B equals 231, because that would make the arithmetic that much harder. We may as well just choose B equals 23. We always want to choose B so it's one of the least non-negative residues. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.